So it's great to be here, and thank you so much for your presentation, Yvonne. It's wonderful to see Apple leading the way on privacy, especially for user data. It's incredibly important and something that we think about a lot at Anthropic. But I'm going to be taking the provider perspective here and trying to give an update on where we are in securing frontier AI. Through that, that journey, you're going to hear a bit about some of the challenges and the threats that we're seeing across the ecosystem. So I'll be touching on that, and I'll touch on confidential computing contribution to the moment that we're living through right now as we try and figure out how we can preserve the defender advantage. So I'm going to make some bold claims. I'm going to try and predict the future at the risk of being wrong about the future. But I think it's important that we contemplate the next couple of years, because each of us in this room is on the defender side. And if we are building for AI that exists today, for the challenges that we think of today, we are going to be sorely disappointed and out of date by the time the future arrives. So with that, I want to inculcate you with this graph yet again. This is the third year in a row that I've been on this stage, not literally this stage, but at the Confidential Computing Summit, saying AI is going to get smarter. It will get smarter, and you must prepare for it. And if there is only one slide that you take away from today, it is this slide. This is a graph of all of the compute that has gone into training AI models since the perceptron in 1957. A year ago on the stage, I presented this graph and said it will keep getting smarter from my perspective at a frontier lab, and lo and behold, it has. And in the last year, since that update, we had the PRC using AI models to launch fully autonomous attacks, which I'll talk about in a second. And we've had the Mythos moment, which I'll also touch on as well. The thing to remember from that graph is that as models get smarter, they will be able to do long horizon tasks. They will be able to be better at cybersecurity. And increasingly, there will be other threats from things like bio or other sort of agentic insider risk threats that we have to consider as we're thinking about defending. So in November, we disclosed the existence of an attack that had been launched by a PRC-affiliated entity. That entity used Anthropic's model to launch attacks against a number of institutions in Southeast Asia. They used jailbreaks and bypasses to compromise our systems. This was covered quite broadly in the press at the time. And then earlier that year, we had disclosed other examples of the models being used in offensive ways, both in open weights models on things sort of open, broad access platforms where abuse can be sometimes hard to find. So this pattern is now well entrenched in the threat ecosystem and the threat landscape. So when we talk about any kind of an attack now, one of the standard TTPs that we look for from threat actors is which models are they using? Which platforms are they using to launch their attacks? Are they running on-prem models? Do we see MCP signatures in the attack path? This is incredible step change in the efficacy of these organizations. And one of the things that we've historically done to attribute the threat actor involved with any particular thing is, especially nation-state actors tend to work 9-to-5 jobs Monday through Friday in the geographic region where they operate. Now with autonomous agents, they can run 24/7, and increasingly it's becoming quite difficult to attribute. But we're seeing continued attacks, and we'll continue to disclose them as we find them. And so everyone in this room is aware of Mythos. I was in a room yesterday with a room full of executives from some big companies, and I think a lot of folks have gotten almost tired of hearing about Mythos. I think many of us have heard Mythos multiple times per day for the last 2 months, and many of us in this room have had our Q2 or Q3 plans completely blown up by the consequences of this disclosure and the model changes that are now being promulgated through frontier labs. There's so much to say about this, but I do think that one of the reasons that it's worth mentioning again that this is important, if it was not obvious from our communication on this, I need to stress it again. the Mythos moment, the cybersecurity capabilities of this model were an accident. We did not intend to create a cyber model. This was a model which is generally intelligent, however you define it, on certain benchmarks. And as a consequence of it simply attempting to get better at coding through reinforcement learning techniques, it became extremely good at cybersecurity. Some of the examples that have been used, there's examples of, public disclosures from parties who are not us, including the UK AC, on attacking critical infrastructure simulation environments, to public blog disclosures from folks like Firefox and Chrome, and then partners across the Glasswing set of companies, which is approximately 200 companies now, on just how capable this model is at discovering cybersecurity vulnerabilities. To be clear, connect this to the graph that I showed at the beginning of the slide. It's been 3 months since we had this model come off of our production line. And I can tell you from inside of a frontier lab, the models are gonna get smarter. And if they're gonna get smarter at cybersecurity as well. And so this is just the beginning of probably 2 or 3 more cranks of the capabilities on the cybersecurity landscape. And as we think about the consequences for the implications of a model accidentally discovering cybersecurity capability, we must price in that every model on the planet will eventually have this capability. And so the question becomes, when? I'll talk about that in a second. But before we get there, I want to strike a note of optimism. This is a bold claim, and I realize that often when you're speaking from a frontier lab, people don't necessarily think that we are being completely honest with regard to like hype and the sort of the way that we speak about the future. But it is so important that we plan for this that it is worth saying again. Everything that we're saying and everything that we're doing in public is an attempt to prepare everyone for what's coming. So, why am I claiming that the permanent defender advantage is coming? Imagine that you're a company in Glasswing right now. You have access to advanced cyber capabilities, and you're looking at the possibility that in a few months, maybe a year, there will be this level of cyber capability in every open weights model on the planet. So you're asking yourself, okay, in 2027, I'm going to release a product, let's say product X, whatever that is. And within hours of me releasing that product, some teenager using an open weights model, living in their mom's basement, say, may be able to find a remote code execution vulnerability in the software that I literally just put out the door minutes ago. And in an hour or two, that kind of vulnerability can be discovered by an open weights model. I cannot have my launch day be ruined by that kind of discovery. I cannot have a world where I ship security bugs and someone else finds them immediately. That is not going to inspire trust. That is not going to make my customers happy. It's going to make me have a very bad day on my launch. So, therefore, I will put these advanced capabilities in every part of my software release cycle. Everything in the SDLC, from the CI pipeline to the CD environment to our automated pen testing that we run against our staging environment, whatever it is, we are going to put advanced models in there. And it might be at first that it's quite expensive and it is latency sensitive, but the cost of models go down. Open weights models are an example of this, right? We will see the proliferation of this capability going across the entire ecosystem. And while, yes, it is today the case that Mythos-class models are the models capable of doing this, and they are very expensive, the thing that AI labs do, what we do as companies, is we find ways to put more intelligence in less neurons, to run more intelligence on less hardware. So if you compare today, for example, Haiku 4.5 to the intelligence of GPT-4 from 3 years ago on the same benchmarks, Haiku 4.5, as dumb as it is, and it's a very cute and adorable Claude, it is capable of doing things far in advance of what GPT-4 was capable of doing 3 years ago. And because of this scaling laws of implication of the cost, it will be the case that literally every software company within, let's say, 2 or 3 years will have cheap, ubiquitous, cyber-capable models running in every part of their CI and CD pipeline. We will not ship security bugs anymore. Now, I know this is a bold claim, and some of you in the audience are probably thinking, what about the halting problem? This seems like a claim that's out of alignment with what I know to be true about cybersecurity. The thing is, software can only be wrong in so many ways that are also useful for an attacker. And that is an advantage that we have the opportunity to take advantage of in these, these techniques for securing the pipeline. So how much time do we actually have? This is a graph that Claude and I, using Mythos, made in the last couple of days. The one caveat to this graph that I want to make right before I say what I'm about to say is that GLM 5.2 just came out, and I have not been able to find any reliable source for cyber benchmarks. For some strange reason, they dropped all of their cyber claims from their model card for the GLM 5.2 release. So I don't know what's going on there, but with a small caveat to that, Claude is concluding that there's approximately a 12-month difference between open weights models and proprietary models. I actually think that's too long. So my best guess, based on all the intel that I have, what I can see inside of a frontier lab, what we know about especially Chinese lab advances and model capabilities, is that we approximately have 7 to 10 months from now. 7 to 10 months from now before an open weights model has advanced cyber capabilities of the class that I'm referring to here. So that means we as defenders in this room have an opportunity to harden our systems before that 15-year-old example that I gave earlier. And if we can do that, if we can use this lead to succeed at defending and hardening our systems, we will not have a vulnpocalypse, as some people have said. Yes, there will be many vulnerabilities. Yes, we will have to patch a lot of them, but we have a lot to do. And so what does that look like? What does that 7 to 10 month time look like? A couple of things. The week that we made the Mythos announcement, that was a very long week. I think I worked like 100 hours, not a lot of sleep. But we did manage to put out sort of an emergency blog post to say, like, if you're a CISO and you're reading this, please do these things to prepare yourself for what's coming. I'm going to take 3 things from that briefly and touch on them, and I'll touch on confidential computing's contribution to the landscape here. So the first is that we must actually, for real today, take seriously what we've been saying for more than a decade on the defender side. Zero trust matters. Zero trust networking became a bit of a marketing term, and a lot of folks started ignoring it because it seemed to be completely overloaded with specious claims. But if you just go back and look at the 2015-ish Google Beyond Corp paper and think to yourself as you're looking at your defensive playbook, we have to be in a world where every network connection inside of our corporate network is coming from a trusted device that matches the device in our inventory, has hardware root of trust in the way that we make network connections. Many of the technologies that underpin that claim are like very part of the TCB for making confidential computing work. And so there's like a huge synergy between making sure that we have zero trust networking. There's many products in this space that you can use from startups that help you achieve this, but we have to do this now. This is not optional anymore. They will get in, the bad guys will get in, and they will be using AI on the attack path. And so we must design for a world where there is no opportunity for an attacker to leap from one breached device to another. The second thing, as models get more intelligent, the one place in your security program where you can take the most obvious benefits of intelligence increasing is to use the models on your detection and response program. So if you are hunting for intruders and you're using AI models to drive your SOC, when there's like 60 different startups doing fully autonomous SOC at this point, including all of the incumbents, folks like Palo Alto and CrowdStrike and Arctic Wolf and others, you have an opportunity to benefit from the intelligence of models getting smarter at the same time the attackers are. So if you invest in AI on the defensive side, you can find the bad guys and stop them before anybody else does. And then obviously we have to do something about vulnerability remediation. So vulnerability remediation in this case may mean fully autonomous upgrades. It may mean something as simple as running a traditional, a high-end crit, vulnerability remediation program with SLAs. However you do it, there has to be some solution. There's of course lots of options in this space to reduce the total surface, and if we're actually really facing a tsunami of new vulnerabilities, then perhaps most of your SLAs will go out the window and you will be quite behind the 8 ball on this. At Anthropic, we're using AI to remediate these as you'd expect, but you don't have to necessarily adopt AI to solve this. You just have to have a plan. Okay, so how does this connect to confidential computing? So in the last 2 years on this stage, I was here saying, hey, it's possible if we do the right things to invest in the right sets of technology to make it possible for protecting model weights as we approach AGI. And it is still true today that if we want to preserve the defender advantage, we have to be in a world where we don't leak these incredible capabilities to adversaries. We don't have a world where we lose the 7 to 10 month lead. So it's not just about not leaking, it's also about enabling defenders. So I know that many in this audience are quite frustrated that they have not been able to access Mythos. I can't say any much more about that for obvious reasons and in this forum, but it is the case that we will get to the point where there is ubiquitous defender access to these advanced cyber capabilities, whether it's through KYC type programs or other programs where we understand who the defenders are and that the good guys are using it for good. And to do this, we need to be able to distribute the model in ubiquitous geographic locations against customers across all parts of the economy, both in the United States and in allied nations. And to do that, we have to, as a frontier lab, whether you're Anthropic or OpenAI or Google, have confidence that as we're doing those deployments, as we're making and scaling up data centers all over the planet, that we do not leak the intellectual property. I cannot tell you how fast and how incredibly arduous teams are working to get deployments out as fast as possible. But confidential computing is now a critical part of the story here. If we can bring a data center online when we know nothing about the people who run it, and we know nothing about the HVAC system or whatever the concerns are, but we know that we have a TCB and we have confidential computing, we have an opportunity to deploy models in places where we would not have previously been able to do. So I'm extremely optimistic. Every chip provider that matters today has said confidential computing is a priority for us. Incredible advances from folks like Apple on PCC have driven demand for effort in this space. We've seen huge investments in the software stack to make sure that it's possible for us to achieve this from companies like Opaque. So much is going on across the ecosystem. There seems to finally be universal agreement that this is an important part of both the user privacy and the intellectual property concerns of all of the players in the ecosystem. And so there may be a path for us to achieve AGI with all of the puzzle pieces in place to secure these models against attackers. As I said earlier, we can only win if we make it possible for defenders to get access to the capabilities that I'm talking about, the people in this room, to actually secure their software. And doing that is only possible through the confidential computing contributions. And then finally, as we think about what every bit of deployment at scale looks like, it's not just chip makers, it's not just data center providers, it's not just frontier labs. Increasingly, the regulatory environment is pointing to confidential computing as part of the solution, where we understand that from an auditing, from a control perspective, from a governmental concern perspective, that as we talk through some of the worst possible scenarios that we might plan for from a national security perspective, confidential computing is part of the answer. It's part of the solution to those problems. And with that, I will end, and thank you so much for listening. Thank you for coming.